So, hi everyone. Thanks for joining. So, people are keep on joining. So, we'll start the session now. Let me introduce our today's speaker, Michael from German. He's the co-founder of Cloudonaut and widdix.com, and he's the independent consultant. He's doing all his consulting work with his brother. We both of us know each other very well, and I just had a discussion with Michael a couple of weeks back, and I was very interested very much with him to host one of the session for AWS User Group Chennai today, and he's going to talk about some of the AWS interesting event-driven system and how you can generate all these reports in case if you required a CSV kind of a report for consolidated reporting. So this is something a real-time use case he was talking about. I was very interested to listen his talk. Maybe without wasting the time, I'll hand it over to Michael. Michael, just handing over to you.
Yeah, thank you very much for the introduction, and thank you very much for tuning in. So I'm going to talk about this topic when event-driven systems meet CSV reports. And I will show you what I mean by that in a minute. So first, I think I like all the important things you already mentioned. So my name is Michael Wittig, and I'm from Germany, and I mostly work on a website called Cloudonaut.io these days, where we publish blog posts and podcast episodes and also videos for our subscribers. So feel free to check that out later. And if you have any comments regarding this talk or any other topic, you can find me on Twitter. So my Twitter handle is hellomichibai. So feel free to reach out to me on Twitter or on LinkedIn if you wish. So what do I mean if I talk about event-driven systems? So I have two examples for you. And the first one is a little bit more traditional. So there is an SQS queue. You can see this here at the left-hand side, where producers add messages to this queue. And then we have this pool of EC2 instances running in an auto-scaling group, and they process the messages. And once they are done, they, in this case, they publish a message to an SNS topic. And on this SNS topic, you can imagine there is then again another fleet of machines or other systems who are interested in those events. So this is, I would say, more the traditional event-driven system on AWS. But we also have the more, I would say, more modern approach where we have, for example, a Kinesis data stream at the beginning. So, for example, the website ingests the data directly to the data stream. Then we have a Lambda function who gets the events out of the data stream. And it does something, maybe runs some business logic. And then it, in this case, pushes the result to an event bus that is provided by EventBridge. So as you can see, there are many AWS services that can be used in an event-driven way. And I really like this architecture approach because it is easier to scale, it is easier to deploy without the downtime, and it also provides this kind of buffer in terms of short spikes of capacity, because the SQS queue kind of acts as a buffer as well as the Kinesis data stream. So there are many advantages to this architecture. But when we were building a system, we were going with the first approach. So we have an SQS queue, we have a fleet of EC2s, and we have an SNS topic. So that's the architecture of the application that I was working with. And then we received an email from our customer. And our customer was asking for something like this. So they wanted to look at all the data in a single file. So this is a CSV file. So you can open it up with any tool for humans. You can also easily process it in other systems. So the problem here is that we are now switching from an event-driven system to kind of this view where we have to keep a record of all the events. So this was not something that we supported with our architecture. So basically, I was in a bad situation because we haven't planned for that. Our architecture was not really able to do that because it was kind of a fire and forget architecture. So I sat down and I looked at the options that AWS provides. And lucky me, AWS released a new feature a couple of weeks before that really helped me to solve this problem. And that's what I'm going to share with you today. So how we can turn this event stream that we get from such a system into a CSV report. And the cool thing, it really works across many use cases. So it doesn't only work with a single use case. So how does the solution look like? And I will provide you a very short overview of the solution now, and then we dive into each and every component that is used. And at the end, we have a summary where we look again at the whole architecture. And this is where I think you should have a good overview of how everything works. So let's get started. So in my example, I start with an SNS topic, but this could be anything else like Kinesis data stream or other AWS services. But in my use case, this was an SNS topic. So all the events were pushed to an SNS topic. And what I did then, I subscribed the SNS topic to a Kinesis Firehose delivery stream. And the Kinesis Firehose delivery stream is basically the key piece for collecting the events, and then it pushes files onto an S3 bucket. And those files contains many events at once. So it's not one file per event, it's one file that contains many events. So that's a key part of the architecture. What you can also see is that we then use Athena to look at the files in the S3 bucket. So Athena is kind of a query engine where you can enter a SQL query and it runs against, for example, an S3 bucket, collects the data and returns the result. And so that's what Athena is all about. And the cool thing about Athena is that it can produce CSV files. So it kind of helps me to achieve my end goal. So what I also did is to make this a little bit more powerful and to have more capabilities, I added a step function state machine in front of it, which triggers Athena queries, but it can run multiple queries and it can run them in parallel, for example. And if something goes wrong, it retries and things like that. So that's why I added a state machine here. And it also triggers a Lambda function at the end. And the Lambda function, basically, it generates the nice report and sends it out as an email. So that's what the Lambda function does. So that's kind of optional. It's not required. What I also did is at the top of the architecture, I triggered the whole step function thing with a event bridge rule, which is triggered every, for example, in my case, every day or every week to generate a daily or weekly report. So that's the architecture and that's the solution. And I was really happy about the architecture because it is very convenient to operate. So there are basically no pieces in this architecture that you really have to manage. It's all it uses only AWS services that are fully managed. So we don't have to take a lot of care when running this solution. So I'm going to dive into the details now, and we also have a couple of demos while doing that. If you have any questions, then feel free to reach out to us in the meantime, and I will see to answer them at the end of each of the details. All right. So I'm starting with Kinesis Firehose because that's kind of the first thing that really is important to the architecture. So what it does is it turns a stream of events into chunks that it stores in an S3 bucket. And you can configure more or less two options. One is the interval in seconds, and this can be up to 900 seconds, which is 50 minutes. So Kinesis Firehose can wait up to 50 minutes before it writes a new chunk down to S3. So it collects events of the past 50 minutes. The other option that you have is the size of this file, the size in megabytes. This can be up to 128 megabytes. So basically, if your file reaches 120 megabytes first, it is written down to S3, or after 50 minutes, it is written down to S3 as well. So that's my configuration. So my goal was to keep the number of files low. But if you have a different goal, you can also tweak those settings and write to S3 faster, for example. What you can also do, which is also very nice to save costs, is you can turn compression on, which basically means that the incoming data is compressed, for example, in gzip format. There are a couple of other formats supported as well, but this helps you to reduce the file size that you store on S3, which is, I think, very handy, and I enabled it, so it helped me a lot to keep the files small. The missing piece is we have to connect our SNS topic to Kinesis Firehose. And this is actually the piece that I mentioned that was added by AWS a couple of weeks ago. SNS topics can now natively ingest data into a delivery stream. So there is no Lambda function needed anymore that you have to write your own. No, you can directly attach the topic to the delivery stream, and AWS will manage the whole data passing from SNS to the delivery stream, which is pretty cool. If you have experience with Kinesis data streams, then I have one little note here. So in Kinesis Firehose, there are no shards, so you don't have to provision capacity up front. So it's basically a scalable ingestion layer, so you can just add your data into the system. You don't need to worry about shards, which is very handy. And of course, there are limits, so you cannot ingest infinite amounts of data, but the defaults are very high. So I was very happy with that solution where I don't have to manage any shards. All right, so the next piece in the puzzle is where we kind of get the data out of S3 and turn it into a CSV file. And I used Athena for a couple of use cases, but I never realized that it can help me with CSV files as well. So what does Athena do? It runs SQL queries against your S3 buckets. And the data in S3 can be, for example, in JSON format, it can be in CSV files, it can be in Parquet format. So it supports all kinds of different data formats out of the box. To run a query, you need or you have to define a table schema. But this schema is not applied when you insert data. It is only applied when you read data, like when you use Athena. So it is kind of applied on the fly. There's one feature, an optional feature that I will go into details later. It's called Partitions, and I highly recommend use Partitions because it speeds up your queries significantly. And last but not least, one of the features of Athena is that by default, so you don't have to configure anything, it stores the results as a CSV file in S3. So basically, it does all what I need. It looks into the S3 files and it generates a table, like a SQL table, and it writes that down into a CSV file in S3, which is super cool because that's what I need, exactly what I need. So that's great. So, okay, now I talked a lot about how those things work, and I think it is now time to look into the AWS console to see how it looks like, right? So what I'm going to do is I will show you how you can create such a table schema, because that is actually the most, I would say, the most involved task in this whole architecture. And the easiest way that I discovered is to use a AWS service called Clue, because Clue can look into your S3 bucket and it generates or detects the schema based on the data in your bucket. So step one basically is wait some time until enough data is in your S3 bucket. Then you run the Clue crawler to detect the schema. And then you can look at the schema definition and actually see what Clue discovered. And if there are anything like tweaks that you want to do, you can then modify the table schema. So let's switch into the AWS console and do exactly that. So this is the AWS console. Let me switch to the Clue service quickly. All right, I will increase the font size a little bit. Okay, so on the left side, we will see the crawler section. And here we can define new crawlers. So the UI is not working that good, as you can see. So it is a little bit buggy. I don't know. All right, so let's keep that navigation here. So what I'm going to do is I will create a new crawler that looks into an S3 bucket and discovers the schema of my data. So I click the Add Crawler button. I enter a name. So let me name this demo. And now we have to define a couple of things. So for the first page, you can just click next. So we want to crawl data stores and we want to crawl all the folders all the time. We want to connect this to an S3 bucket. So I will select my bucket here. Now I have to be a little bit careful to select the right one. Okay, so that's my bucket. So it is just like a very machine, not so human readable name, but it's just my bucket. And within the data folder, Clue should look into the data and discover the schema. So I don't want to add another data store, so I'm fine with one. I have already created the IAM role, but you can easily, creating one in the UI, just provide a name and that's it, but I will reuse the one that I created before. And now you can ask, or you can tell Clue to run either on demand, which means we have to schedule or trigger the crawler, or you can run it on a schedule. So for example, hourly, daily, weekly, monthly, and so on and so forth. So I will run it on demand because I only want to run it once. I will run, or the table should be written to the default, like the table definition should be written to the default database, and everything should be prefixed with demo. So this just ensures that I'm not overriding any of the existing tables. All right, so that's it. The crawler is defined. I will kick it off now. So I click the run crawler button, and now this will take some time. Depending on the volume of your data, you have to be patient. So I created a crawler up front to make sure that this doesn't take a lot of time for us to wait for. So last time it took around 1 minute. So yeah, that's for example, like for smaller buckets, you can expect that it takes around a minute. If your bucket is really large, lots of data folders, lots of files and large files, it can take longer. So don't be surprised if this takes a couple of minutes. All right, so let me see what tables we have in Athena from my previous run. So I will select a new service, which is called Athena. So that's the service that we use to query the data. And I will just show you how it works. Okay, I'm in the default database and I have a data table. So that's the table that was discovered by this other clue crawler that I created in preparation of this for this meetup. So make sure that we are not wasting time here. And now I will run a query against my bucket. So let me copy that from my notes to make sure that I don't add any typos here. So I increased it a little bit. Okay, today is March 30, so I will change that. So what I do, and if you have any experience with SQL, then this feels natural, right? So I select stars, so all the columns from the table data, where the year is 2021, the month is March, and the day 30, and I limit it to 10 results because I don't want to be, what's wrong here? All right, so nothing is wrong. So sometimes you just have to hit the run query button twice. So that's a bug in the UI. Okay, I have no data returned. Let me switch to 29. Yes, that looks better. All right, so and what we get back as a result is a table. And that's exactly what we need. And now I want to show you that this is actually a table in S3 or a file in S3. So what I'm going to do is, in the meantime, I will switch to the S3 service. So now we are looking at 3 different services at the same time. So sorry for that. I have this Athena bucket here at the top where my, I thought at least that this is the bucket where the results are stored. Let me quickly check that. Oh no, so this is where the results are stored. And this is CSV file by default. So I will open that. And then I will quickly show you how the file looks like. So this is the file. So it contains the 10 entries because I limited it to 10. And it's, in this case, I opened it with numbers, but it's a raw CSV file, comma separated file as expected, contains all the data that we are interested in. So that's the default behavior of Athena, right? I didn't do anything to create the CSV file. It was already there. So that's very convenient. So the last step that I promised is that you can now get an idea of the schema that was generated by Clue. So what you can do is you run the SQL command show create table, and the table is called data. So you can execute this query. And as a result, you get the create table statement that was used by the Clue crawler to generate this table. So as you can see, those are all the columns that we have. I don't think that we need to change anything here. We see that there are some partitions. I will talk about that later. You see that it is it discovered that the data is in JSON format, and we have all kinds of additional information here. It is a gzip, a JSON file, for example, but that was all discovered by Clue. So that's nice. So what I suggest is that you copy and paste this command, this create table command, and then, for example, you apply it to your production account. So don't use the glue crawler in production. Use it in your test or dev account only, and then apply the schema by copying it from this environment here and apply to the other environments. So why do I suggest this behavior? So let me quickly go back to my slide deck. So, all right. Give me 1 second. Okay. So the reason why I don't suggest using the glue crawler for kind of making sure that the schema also exists in production is that I realized that evolving a schema with the glue crawler is kind of risky. So because what happens if your structure changes, like the new files have a different structure than the old ones? Do you want to rename the tables? Do you want to add new tables? Want to remove the old tables? So this is very, I would say, problematic. So I want, because if you change the schema, all your queries have to change as well. So that's why I don't recommend running it like in a continuous fashion, which updates tables. So keep that in mind. I recommend to create the schema manually. So let's talk about partitions. So the query that I executed looked similar to the one that you see here on the screen. So I select star from table where, and then I select the year and the month. And you might think, okay, so how does this data looks on disk? So I have a folder that is named 2021. I have a folder that is for January. Within that, a couple of files. I have a folder for February, a couple of files. And then I have one for March with a single file at the moment. So if I execute this query now, you might expect that Athena will only look into the February folder, right? Because I only am interested in data from February. Turns out that's not the case. So by default, without partitions, Athena will always look at all the files in your bucket. And as you can imagine, if you're only interested in a very small portion of your files, this is a very slow approach. So, and this is where partitions come into play. So with partitions, if I execute the exact same query, and if I have like the partition on the year folder and the month folder, Athena is smart enough to now figure out that it only has to log into this one specific folder. And this is why partitions are so powerful, because no matter how large your S3 bucket is, if you can narrow down the data to a single folder or to a couple of folders, the result will be generated super quickly. So that's why I highly recommend to use partitions. And we will look at that as well. So there are, again, two options to kind of create those partitions. The first is using the glue crawler. The problem is that every day, for example, or every month or every year, when a new partition is added, you have to add this partition as metadata to your table as well. So if you run the glue crawler on a daily basis, for example, it will add those partitions for you, but then it runs on a daily basis. So you again have to think about the cases where what happens if the data structure changes, so what happens to my schema. So that's why I discovered a second option. And the second option is called Partition Projection. So with Partition Projections, you don't need to add partitions while they are created in S3. No, you can predefine them. So you don't need any glue crawler, because you can, when you create the table, you can add the partitions already. So, and that's what I'm going to show you now. So how can you do that? Let me quickly switch into the Athena console once again. All right, so let me switch the database. And here we are going to look at the query that was used. Oh, no, okay. Let me copy that here quickly. That's, I think, faster, yeah. Okay, I go back to the default database as well. Okay, hide that. So I will, okay, this is my new query, and I hope you can see that, so I will increase it a little bit. So I create an external table. So that's exactly the same as before. Now I call it data2 just to make sure that the other name is already used. I use the exact same column description. So this is just copy from the old one. I use the exact same partition by schema. I also use that from Clue. The raw format, it's the same as what Clue discovered. The properties exactly the same. Input format, output format. That's also all the same. Location, all the same. But now we have to be careful. In the table properties, things get different. We keep the classification JSON and the compression type to gzip, but then we have to add a couple of options. And this is where we now define the partitions. So for example, I tell Athena here, okay, this table has a partition. It's called year, and it's of type integer. And the integers are from 2021 up to 2025. I also have a partition called month. It also is of type integer. The range is 1 to 12, including 1 and 12. And it's represented as 2 digits. So if there's only one number, it is represented as 0 and then, for example, 3 for March. I have a third partition. It's called day. It's also an integer. The range is from 1 to 31 because we have up to 31 days. And it is also represented as 2 digits. And then I also said that I want to have projection enabled turn to true. So this enables the partition projection feature. And if I execute this query, a new table is created. A new table schema is created. No, execute this again. Let me see why it's not working. All right. Okay, I'm not sure why it's not working. Oh, now it's working. Okay, so this UI is really crazy. So I haven't changed anything, and now I had to hit the run query button 3 times to make it work. So sorry for that. All right, so what I'm going to do is now I run the exact same query as before, but this time against the data2 table. Keep in mind that this is always backed by the exact same S3 bucket. Just the schema definition is a little bit different this time. So I think that's the same bug. Let's hit that button a couple of times. No. So what's wrong this time? All right, now it's working. And as you can see, again, I get the result, and this is like the exact same result as the one from the previous query. So that's cool. So that's what Athena can do for us. So I highly recommend to use the partition projection feature, because if you do so, you don't have to use Clue to discover the partitions. So that's the big benefit, I would say. So it's much easier to manage, and there are less moving parts here. All right. So we can also have a quick look into what step function does. As I mentioned, step functions is used to orchestrate the queries. Oh, sorry for that. So step functions can natively run Athena queries. So you specify the SQL query, and step functions will execute that. And as a result, you basically get the path to the S3 bucket that contains the result. And in my use case, I run 3 different queries. So I get like a daily list of all the events. I do some aggregation, so based on type, I group by type, for example. And I also get some like top 10 kind of table that I include in the email. So I run 3 different queries, and then I execute a Lambda function with step functions that basically generates the email, like the text and the subject, and then sends it out using SAS to the destination. So that's what I use step functions for. It's not needed. So you could just trigger Athena directly with an event bridge rule, a Lambda function, then execute the Athena query, for example. But I like it because I can orchestrate the work a little bit here. But it's, as I said, not required. So I think one of the important questions about this architecture is, okay, what does it cost? So what are the AWS fees we have to take into account? So first, we pay for the SNS subscription. So SNS subscriptions are priced based on the number of events they process. So the more events you ingest into the SNS topic, the more you pay for the SNS subscription, which kind of makes sense. If you don't ingest any data, you will not pay anything for the subscription. Then we have FireHost. In FireHost, you pay per process gigabyte. So once again, it doesn't matter how many events, it only is the gigabytes that are counted. And if you don't ingest any data, you pay nothing for FireHost. So that's again very different from Kinesis data streams, where you pay for the shard no matter if you use it or not. So then we have S3 in the architecture. So here we have two pricing dimensions that we have to keep in mind. You pay for requests, both for putting data into the bucket and also for getting data out of the bucket. And you pay for the data that is stored in the bucket. So in my case, I use lifecycle rules to remove data after 1 month, because I like the report that looks back into history most is the monthly report. So I know I need 31 days of history. I can get rid of all the other data. So that's why I keep, or this is how I keep my stored gigabytes low and make sure that this is efficient in terms of the costs. Last but not least, you have to pay for Athena as well. And with Athena, you pay for the process gigabytes. And as I mentioned, partitions are useful for performance, and they are also very important to keep your costs down. Because if if Athena has or uses partitions to kind of narrow down your data set, it also doesn't process all the data, which also lowers your cost. So it's faster and it is cheaper to use partitions. So that's why it's really highly recommended. So what we can say about this architecture, that it is truly serverless. So you only pay for usage, you don't pay for idle. So I think that's very good for modern architectures. All right. So time for the summary. We look at the architecture once again from bottom to the top. So we start with an SNS topic, as I said. You can replace the SNS topic with other AWS services. For example, you can replace this with a Kinesis data stream. Kinesis data streams can natively ingest into a delivery stream. You could replace it with AWS IoT, which also can natively ingest into a delivery stream. You could, if you are from the logging, if you have a logging use case, you can use CloudWatch logs to ingest directly into delivery stream. And if you have EventBridge as your data source, you can also hook up EventBridge directly with delivery stream. And if you use any other data source, you can always hook up a Lambda function, connect the Lambda function to your event source, and then push within your Lambda function to the delivery stream. So that's kind of how you can integrate it with other sources. Then, as mentioned, Kinesis Firehose writes to S3 in chunks. So in my case, it's files up to 128 megabytes in size, or every 15 minutes. And then we look at this data with Athena, and luckily Athena produces CSV files out of the box. So the resulting table is always stored as a CSV file in S3 bucket. And then I have this kind of optional components here at the top, where we trigger a step function every day using an EventBridge rule. So this is kind of the cron job mechanism within AWS. It triggers the step function, which runs the Athena queries. And when all the queries are done, it, in my case, executes a Lambda function, which kind of sends out an email to the receiver and basically tells them, okay, here are your new CSV files. Feel free to download them from the bucket. So that's it. That's how I turn events into CSV files. It works very well for us, for our use case. I think it works for other use cases as well. So I hope I showed you that it is kind of a universal approach to turn a stream of events into CSV files. So yeah, that's it for now. We have one little surprise for everyone who watches or is still watching my talk. So thanks for that. I produce exclusive videos and online events for AWS professionals once a week. So this is part of our Cloudonaut.io website. It's called Cloudonaut Plus. We create the videos to inspire our subscribers. We also help them to stay up to date. So we review the latest features, we review the latest services to ensure that you don't burn your hands with these new AWS features. And last but not least, we produce a video each week, which means that if you watch them, you will deepen your AWS knowledge. And what we are going to do here now in this meetup is we have 2 subscriptions, so 2 one-year subscriptions that we raffle, and I think there is a great a little quiz prepared, right? So let's see how that works.
Yes, Michael. Yeah, we have a quiz ready.
All right. So you want to start it, or how does it work?
Sure, let me share my screen. I'll give you the instruction. One second. Let me share my screen. So hope everyone can able to see my screen. Uh, Hey, just open a Kahoot.it website from your mobile or laptop and just enter the pin to join us for the quiz. Let's wait for people to get joined. I see two people, Satya and Venkat. We'll wait 1 more minute.
Yeah, that sounds good.
So then, once we see more people, we'll start the quiz. So how this works? You need to type the right answer, uh, and then at the end it will select the person who answered very quickly as well as number of maximum correct answers. So as of now, we see only two members. Sabarinath, Satya, Venkat. Let's wait for two more folks. Yeah, Krishna. So let's give a few more seconds. Five members join. Rajesh.
And by the way, thanks for all the comments that I see here. So if you have any questions, feel free to ask them in the comments as well, and I will try to do my best to answer them. So while we wait here for a couple of more players to join the game.
Okay, I think we can get started now. Okay, let's start the quiz now. So you just select the color which you think is the correct answer. So you'll see the question and then we give you the 20 seconds. You can select the right answer. So we have 10 questions. Question number one. Just select the right color, right answer, whichever you think is right. Correct. So let me go to the next question. Question number two. So there are 4 right answers. Third question. Cool, 5 right answers. The fourth one. Seven answers. Good. Wow, 4 right answers. So far, Venkat is leading, followed by Rajesh. Let's select the next one. The right answers. Still Venkat leading on the first place. Sixth question. We have 4 more questions. For this question, you need to select 2 right answers. Cool. Okay, the 7th one. Okay, cool. Everyone answered for this question. So the 8th one. Wow, Satya is leading. Cool. Here's the last question. Cool. Let's see who all got selected. The first 2 persons, Satya, Rajesh, and first one goes to Venkat HID. So I think Venkat and Rajesh got the lucky winner, the coupon subscription for 1 year. So Venkat and Rajesh, you just need to contact me and provide your first name, last name, and email ID so that we can send you the subscription details.
Yeah, and congratulations to the winners. I mean, those are very hard questions, and there's also a very exciting race at the end. So that was a great game. Yeah, with great questions. Thank you very much for that. And yeah, reach out to us, and then we can provide you the code for the subscription.
So you can reach out to info@awsugchn.in. Just send your first name, last name, and email ID. We will send you the subscription details. Thank you everyone for joining us today. And thank you for your time, Michael, to sharing your experience and knowledge with us. It's really appreciated.
Yeah, thank you for having me, and thanks for watching. And I hope we see each other again in a couple of months or years in another meetup.
Sure. Yeah, thank you. Thank you everyone. Bye.
Thank you.